Welcome back to a new video of the European project IoT from Internet of Things to Artificial Intelligence. In this video, we are going to review the main concepts that the students will learn in the IoT course in level main. The IoT course is titled Implementing IoT Solutions. In this course, the students will review some of the main concepts already learned in the course Introduction to IoT, mainly the concept of IoT and the concept of thing. Students will also learn the link between IoT technology and 5G. Moreover, we will review in depth some of the main applications of IoT technology, from smart care, smart building, smart factory, to smart grid, smart parking, or smart lighting, among others. It's also important to review the main challenges of IoT technology. There are a lot of concerns developing IoT projects, from scalability, maintenance, connectivity, data security, integration, or cost. Students will learn about the architecture of IoT. There are 4 different layers: application layer, data processing layer, networking layer, and sensors and actuators layer, or also called detection layer. Each layer will be reviewed in depth. We cannot forget that for implementing IoT, we have to take into account that we will work with physical IoT devices, but these devices will be managed as virtual IoT devices in a virtual IoT network, managed by a controller that will communicate with the final applications that are used by the clients. So, you have to know that we are working in a physical environment, but we are managing our IoT network with a virtual technology, virtual management, virtual services, and so on. During this course, the students will learn that there are a lot of IoT kits for starting in the IoT technology. We will review some of the most popular, like Mongoose Operating System IoT Starter Kit, IoT Kit for Arduino, Starter Kit for IoT based on Raspberry Pi, or Sigfox IoT Starter Kit. But we will also learn that there are many commercial IoT devices, and sometimes it's not easy to know which device to buy. It will depend on the scenario, the features, work range, price, protocols, and roles. It's very important to distinguish between the different technologies and protocols in the framework of IoT. There are some popular technologies like Bluetooth, Wi-Fi, Zigbee, NFC, or cellular networks, but there are also some specific technologies and protocols designed only for IoT networks, like Zigbee, LoRaWAN, Sigfox, or Z-Wave. The students will learn about the communication technologies and protocols from the point of view of IP protocol. We use IP version 4 when we want to connect to internet our devices, laptop, PC, or tablet, for example. However, there is a lack of enough IP addresses for all the devices that will compose IoT networks around the world. So IP version 6 is expected to be mainly used for IoT networks. They have more IP addresses to have a unique identifier for each IoT device in the world. In this course, the students will also learn about the concept of IoT device management. IoT device management, or IoT DM, is the process of authentication, provisioning, configuration, monitoring, and maintenance of the device firmware and software that provides its functional capabilities. It's a software tool that is in the middle between the sensors and actuators installed and the user interfaces or final user application. This device management is used by the device manager. You can see here like one snapshot of a device manager tool that is included in an IoT platform. The device manager permits the visualization of the different parameters that are being measured by the IoT devices. The user, thanks to the device manager, can also perform the configuration of alarms, attributes to connect or disconnect devices, and so on. We have to know that there are different levels of devices in an IoT network. The non-managed devices, the semi-managed devices, and the fully managed devices. These devices are mainly managed through the software component called device agents. Finally, we will review in depth the IoT platforms. There are a lot of IoT platforms in the market. Some of them are free, some of them are paid, like Google Cloud Platform, Arbor ICT, Amazon IoT Core, Salesforce IoT Cloud, or Microsoft Azure IoT Suite. From all these IoT platforms, we can also find the open source platforms like Thinger.io, OpenRemote, Fireware, or ThingsBoard, among others. Here, you can see a snapshot of the main screen of each of these platforms. For instance, for Arduino, for OpenRemote, ThingsBoard, Things.io, etc. It's important to remark that IoT is one of the most promising technologies related to digital transformation, and IoT has blossomed as a suitable solution to adapt business processes and procedures to a COVID-19 scenario. In fact, the OpenMind BBVA initiative has identified 4 major areas where IoT provides special benefits to face the social challenge derived by the COVID-19. Work from home, blockchain, telemedicine, and e-commerce. This course is finished with a practical exercise. This practical exercise will be performed with the tool Cap Carbon. In this tool, we are going to work with a smart city and Internet of Things wireless sensor network. This will be managed thanks to a simulator. The goal of this task is to design, visualize, debug, and validate distributed algorithms for monitoring environmental data collection, etc. The goal is to create environmental scenarios such as fire, gas, mobile, and in general within educational and scientific projects. So the students will have to install Java and Java runtime environment before to install Cap Carbon IoT Simulator. After that, there will be 2 practice lessons, Hello World and Reading Digital Sensors Value. Thanks for watching, and if you have any doubt, don't hesitate to contact us.